My plan today is to introduce tangent and cotangent. They are a little bit different than sine and cosine, and thus secant and cosecant. But my plan is to introduce tangent and cotangent, and then we'll probably look at the actual examples tomorrow would be my guess. When we did sine and cosine, then secant and cosecant followed directly because they were just kind of attachments to those graphs. Tangent and cotangent are different. You can find them if you're looking in your book in lesson 4.5, it's the second part of lesson 4.5. As you look at tangent and cotangent, what you will notice is they are just these curves. Okay? They are just multiple repeated curves. If you ask me, they kind of look like the cubic curve, right? The y equals x cubed. They look very similar to y equals x cubed. And what I'm actually showing you here is actually 2 cycles. So the one thing I will change up is instead of saying minimum 1 cycle, I'm going to say minimum 2 cycles here. But what is being shown here is 2 cycles. Okay, so tangent. With tangent, you'll notice it says the first thing you'll draw is the dot on the origin. And, okay, a couple of things that change. First of all, the period of tangent. If I'm going to tell you that that is 2 cycles showing, well, keep in mind, that means 1 cycle, and I think of it as asymptote to asymptote. 1 cycle goes from negative pi over 2 to positive pi over 2. Another cycle goes from positive pi over 2 to 3 pi over 2. 1 cycle is equivalent, instead of 2 pi, 1 cycle is equivalent to pi. So your period in tangent and cotangent is just pi. What's going to happen is, okay, so for tangent, you'll notice it says you draw the point on the origin first. So you're going to have a point once every period. So if there's a point at 0, then you have a point at pi. Then the next point would be at 2 pi and 3 pi. You'd have a point once every period. Now the halfway point in between those periods is going to be the asymptotes. So there'd be asymptotes at all the halves here. Pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. You will notice that the tangent is an increasing curve. It starts low and it is increasing. As I said, I think of it as a y equals x cubed. Now, one connection. I know most of us will just kind of memorize that, okay, tangent starts on a point, but a connection I can make for you. How does tangent relate to sine and cosine? Do you remember this?
Y over x.
Okay, tangent is y over x, where y is representative of sine x and x is representative of cosine x. So the idea, tangent, is sine divided by cosine. Well, keep in mind, cosine's on the bottom. What can the bottom of a fraction never do? Denominator of a fraction can never equal 0. So think about, when does cosine equal 0? Well, if you think about a cosine curve, I'm just going to put this on here and then I will take it off. So cosine curve, what? It starts high, it cuts through there, it has a minimum, it cuts through there. That's the idea of a cosine curve, isn't it? Notice what happens where the cosine curve equals 0. In the tangent, there are asymptotes. And that's because cosine is in the denominator. It can never equal 0. Now, if I take that off, think about sine. What's a sine do? Sine starts at the center, goes up, crosses through, goes down, crosses through. When sine is on top of a fraction, notice what's happening. When sine equals 0, tangent equals 0. So those zeros, those points on the curve, are matching up. Okay, that's a connection you can make if you forget, okay, I don't remember how to draw a tangent. That's a connection you can make. is that the zeros of cosine, so your cosine zeros, will be asymptotes of tangent. And your sine zeros, your zeros of sine, will be zeros in tangent. Okay, so this is just kind of some information to help along the way. Again, you can kind of memorize how we do these graphs. You don't necessarily have to know this information, but I think it's helpful. That the numerator of tangent is sine, so I place sine as a 0, tangent has a 0. The denominator of tangent is cosine. Denominators cannot equal 0. So any place cosine has a 0, tangent will have an asymptote. Okay, that was tangent. Cotangent. Notice it says the first thing you'll draw in cotangent is the asymptote. Okay, so the idea is, instead of starting with a point, it's shifted over a little bit, and you start with an asymptote. Again, asymptotes happen once every period. What's my period? How often are asymptotes happening? 1 pi, 2 pi, 3 pi, 4 pi. So just like tangent, the period is the length of pi. Okay, so that's one big thing to keep straight. Sine and cosine, the period was 2 pi. Tangent, cotangent, my period is 1 pi. And then, okay, so we have asymptotes on all the whole pi's, so once every period. And then what's going to go in between the asymptotes? That is your zeros. So the points, the zeros, in this case, are happening in the middle of the asymptotes. You also notice with the cotangent curve that the graph is decreasing. It's like a reflected tangent curve, or a reflected x to the third curve. Like I did up above, we can think about a fraction. If tangent is y over x, then cotangent is x over y. Or in other words, cosine over sine. Well, I can do the same thing I did last time. This time, cosine is on top. So any place cosine has a 0, anytime cosine equals 0, then cotangent will equal 0. Notice a cosine curve does something like that. It's going to match up on those zeros, isn't it? Whereas a sine curve does something like that, right? Sine is in the denominator. Whenever sine equals 0, because it's in the denominator, you're going to see asymptotes whenever sine equals 0. So this time I can say sine zeros are going to equal asymptotes. And cosine zeros are just going to be zeros for cotangent. So that's a little bit of information there about cotangent. You'll notice your chart is a little different on tangent, isn't it? Sine and cosine, we had our chart with everything about all the information about period and centerline, amplitude, period, phase shift. Our chart changes up a little bit, similar but yet different. As you look at this, A, what was A previously? We called A the amplitude. Well, we don't really call it the amplitude here. I mean, it's still doing the same thing in a way, but we think of it differently because amplitude is how much are we stretching or shrinking that graph, right? How much are we pulling it away from the x-axis? Well, we can't really stretch these up and down as much in terms of, having a number here. So what we're going to talk about is we're going to go back to our stretch and flatten. Flatten being the idea of a shrink. And if your amplitude value is a number bigger than 1, then that's going to stretch it up. And that's going to pull it away from the x-axis quicker. And I'll kind of show that as when we graph some of these examples, probably tomorrow, I'll kind of explain how that works and how you should show it on your graph. Whereas, if the a value out front is a number less than 1, so basically something between 0 and 1, it's going to flatten it. And so that means it's going to stay closer to the x-axis along the way. Okay, so I'll help you explain the difference between those and how you show that. If a is negative, there's still going to be a reflection. That part hasn't changed. It just means, like if you reflect this, when you reflect a cotangent curve, it's basically going to look like a tangent curve. Okay? Notice, here's the big change. What was our period previously? 2 pi divided by b. But now my period is pi divided by b. Why is my period pi divided by b? Because my basic period is only 1 pi. So, of course, then my period, when we find it, is going to be 1 pi divided by b. So that is the big one that changes. B is still the coefficient of x, but that's the big one that changes. Phase shift is still c over b, and center line is still d. The thing is, you'll just label the center line. You won't have an amplitude label with this one. Okay? I'm not sure there's really any point in starting the first example because we'll get cut off rudely in the middle, won't we? So, tomorrow, my plan will be to go through some or maybe even all 4 of the examples. Okay, that'll be my plan tomorrow. Then that will put tangent, cotangent due on Monday. And that will put me handing out a review worksheet on Monday over all the 6 type graphs. And I'm thinking quiz on Wednesday. And the quiz will look a lot like the worksheets, right? Okay, so that's where I'm thinking.